Okay, so the exclusive OR of T and Q is the same as saying T prime Q or TQ prime. And so in this instance, that would be Q star equals T prime, so QY or X bar or Q bar Y bar, and then the not of all of that, so that's T prime and then Q, or T, which is this, QY plus X bar plus Q bar Y bar times Q bar. Okay, now for this first one here, we have to use De Morgan's law. So De Morgan's law tells us that that is QY bar ANDed with X bar bar, which is just X. Okay, when I have three things, it doesn't work. Gosh, okay, this one gets complicated. Well, I'll just... Let me see if I think this one is worth doing. Hold on. I don't think it's worth spending all the time for me to do the Boolean algebra on this. So let's just let's believe that in fact it does end up being the XY flip-flop that we had before. I don't think we'll get a whole lot of benefit out of my doing all this Boolean algebra unless y'all really want me to, in which case I'll do it later because I want to make sure I have more time to do the stuff that I think is more useful. Any objections to that?
Nope.
Okay. So the main thing here, so the main takeaway from this is, first you get your excitation equation. That's what you get from the circuit over here. And that's what I did when I did this. Then you find the characteristic equation of your particular flip-flop. So like, for instance, if you had a JK flip-flop, we said the characteristic equation for the JK flip-flop was this. So you would take whatever expression you got for J and you'd plug it in here, and whatever expression you got for K and you'd plug it in here, and then you would simplify whatever you had. So now, and that was like, yeah, so that's what you would do. But then to get your characteristic table, I did not do a characteristic table last time. I mean a state table. I'm sorry, I did not do a state table on problem 1. I did do I did do the state diagram, but I forgot to do the state table. So it's the same flip-flop because we were just showing this the same flip-flop, but we're going to see how to do a state table for it. So state table, the way that works is you have your present state is one column, and then you have your next state, and your next state depends on your inputs. And so we have two inputs, and they could be xy equals 0, 0, xy equals 0, 1, xy equals 1, 0, or xy equals 0, 0. And in our particular example, it's a single flip-flop, so it only has two different states. When you just have one flip-flop, you have two states. If you have two flip-flops, then you'd have 4 states. If you had 3 flip-flops, then you'd have 8 states. But we only have 2 states, and our states are 0 and 1. And then if you go and look at what we had back in problem 1, based on our input, when we were in state 0. So we were in state 0, and we had inputs of 0, 0, 0, 1, or 1, 1. Then we went, oh wait, I'm going backwards. So if I'm in state 1, and I had inputs of 0, 0, 0, 1, or 1, 1, then I went to state 0. So 0, 0, 0, 1, or 1, 1, 0, 0, 0, 1, or that should have been a 1, 1. So if I was in state 1 and I had any of those, then I went to state 0. If instead I had an input of 1, 0, so if I'm in state 1 and I had an input of 1, 0, I went back to state 1. If I was in state 0 and I had an input of 0, 0, 0, 1, or 1, 0, so in other words, anything but 1, 1. So if I was in state 0 and I had anything other than 1, 1, I went to state 1. And when I was in state 0 and I got an input of 1, 1, then I went to state 0. Oh, wait, is that right? Yeah. Yeah, that's right. For some reason it just looks funny to me. Okay, so that is a state diagram. A lot of times what we do is, rather than use numbers, because later on you will have states that have more than one flip-flop, so you'll have more than just 0, 1. We'll have names for them. And so when you just have two of them, nice names can be S0 and S1. And so doing your state table with names, that's the easiest part of that, of this problem. That all you do for that is you just take your state table I believe your book calls this a state table, and the next thing I'm about to do, a state assigned table. It's not that different. So we can also draw this as such. You've got present state and next state. And if I wanted to be really abbreviated, I could just do x bar, y bar, x bar, y, x, y bar, and xy. And this is state S0, this is state S1. And I just replace my 1s with its name, with S1, and I replace the zeros with S0s. So, so that's a nice state table. All right. So now let's take a look at my last problem, which is, what did I say to do? I said create an SR flip-flop using a T flip-flop and or not gates as needed. Okay, so this one says to create an SR flip-flop. So we're going to follow this using an SR flip-flop, but it doesn't have to be an SR flip-flop as long as you know what its functionality is supposed to be. So if you know what its functionality is supposed to be, you would do something similar to what I'm doing right now. So I do need to know what the functionality is. And so I'm going to write a truth table for an SR flip-flop. If I had a different type of flip-flop rather than an SR flip-flop, like if I was doing my XY flip-flop from before, I would just have XY. And so I'm going to have that, and I'm going to have a present state, and I'll have my next state right here, and I'll have my 8 possibilities. And for an SR flip-flop, this is going to be a little different. So this is going to have a little something extra that you won't have in your homework. I have don't cares for these last two rather than numbers, because for an SR we try to avoid the 1-1 output. But when S and R are both 0, we have no change. When S is 0 and R is 1, we have 0. When S is 1 and R is 0, we have 1. Okay, so that's our table for an SR flip-flop. So, but I'm using a T flip-flop. So I also need to know what a T flip-flop does. So I'm going to write that over here. If I was using a D flip-flop, I might have that. There's not, D flip-flop is pretty easy, but I'd still have it. I'd still have the same thing. So I'll have 0, 0, 0, 1, 1, 0, 1, 1. And my Q star, when T is 0, there is no change. And when T is 1, there is a toggle. So if this was a D flip-flop, I would have the same thing, just Q star would be 0, 0, 1, 1. Okay, so now what I want to do is to figure out how to get these two things together. So I need to build this flip-flop using a T flip-flop. So here's what I need to do. So I'm going to put a column over here on this table, and I'm going to, up here, I'm going to write my T input. And I need to make sure that when my SR inputs are what they are over here, that corresponds to a T input that would give me the correct output right here. Okay, so let's see how that works. So I want to know that what input do I need for a T that will give me when Q is 0, so Q is 0, what T input is, I don't know why I put Q bar here, this is Q star. Y'all have to tell me when I make mistakes, because I make lots of them. So when Q is 0, so here in my T table, here's where Q is 0. When Q is 0, what T input gives me a Q star of 0? So I need, when Q is 0, I need a Q star of 0. My T input that does that is 0. So I'm going to put a 0 in this column. Okay, now this next row, I have Q is 1, and I need to know what T input will give me a Q star of 1 when my Q is 1. Okay, so Q is 1. So Q is 1. What does my T input need to be so that Q star is 1? My T input needs to be 0. Okay, so let's do the next row. Okay, so now Q is 0. So now I'm looking at the rows where Q is 0. That would be, so these, I'll put them in red. The red rows are where Q is 0. So when Q is 0, what T input will give me an output of 0? So Q is 0. I need my output to be 0. That's this row, and that corresponds to a T of 0. So I get T of 0 again. The next one, Q is 1. So that'll be this color. Q is 1. So when Q is 1, what T input gives me an output of 0? So Q is 1, I need an output of 0. That would be when T is 1. Here Q is, the next row Q is 0. So Q is 0, those are our red rows here. I need my output to be 1. That's this row right here. That means I need my input to be 1. And this one, Q is 1. So those are our kind of bluish ones. So Q is 1. I need my output to be 1. And so if Q is 1 and I need my output to be 1, I need T to be 0. And I don't care about the last two. Okay, so now what do I do with that information? So what I do with that information is as follows. Okay, so now this was my T input. So I'm going to do a Carnot map. What I'm doing is I'm deriving my excitation equation for T. So I'm going to have, I'm going to live dangerously and not do this in the same order as on my notes. I'll have SR here and Q here. 0, 0, 1, 0, 1, 1, 1, 0, and 0 and 1. And I am saying I'm coming up with the equation for what do I need T to equal in order for this whole thing to work. So I look at this column that I made for T, and I have a 1, so I'm looking at SR and Q. So when S is 0, R is 1. Oh, yeah, look, I can't do a Carnot map. S is 0, R is 1, and Q is 1. That's right here. This is supposed to be 0, 1. S is 1, R is 0, and Q is 0. That's right here. And I have some don't cares where S and R are both 1. And so I can get, I think this is probably the best. So I would say that T equals S Q bar or RQ. Okay, so now what that tells me is I'm supposed to be building this SR flip-flop out of a T flip-flop. So I have my T flip-flop, T, and my output is Q. I can have a Q bar. I have a clock, and my inputs are S and R. And I need my input into the T flip-flop to be defined by this equation that I wrote up here. So I have two AND gates and an OR gate. And I have S and R. So I have S and Q bar. And I have R and Q. And then I have the OR of those. And see if that matches what I have here. Oh, and I have a clock. Two AND gates, R, that's Q. That says, yep, that matches what I have there. So, so my basic idea was, so going through this, let's see what I needed to do. Let me just take a quick look. Okay. So, I had some behavior that I wanted to create. In my example, I wanted to create an SR flip-flop, but it could be any behavior that I wanted to create. So I had that, and then I made my truth table for that. And then I wanted to use a T flip-flop for this. So I wanted to use some sort of flip-flop for it. And so I needed to know how that flip-flop behaved as well. So I had my truth table for the behavior that I wanted to create. I had the truth table for the flip-flop that I had to use. And then what I did was I kind of worked backwards. I said, I looked at what input of the flip-flop that I needed to use, what input would I need in order to get the output needed for the behavior over here. So what I did was, for each row in my table for the behavior that I wanted to create, I looked at my Q and Q star. So I looked at my Q and Q star, and then I came over to my T table, and I said, if I have this Q and this Q star, so 0, 0, I have this Q and this Q star, what does my T input need to be? It needs to be 0. And then I would look at this one right here. So if I have this Q and this Q star, 0, 1, 0, 1, what T input do I need? I needed 1. Now, I'll do one more. Let's say I had 1, 0. So my Q and Q star was 1, 0. That's right here. What T input did I need? I needed a 1. So I needed that. So then I built up this side to show what T input I needed. So now I had, this is the T input I need to create this Q star behavior. But then I had to figure out, okay, well, how does that match with my SR and Q? So then I took my SR and Q and I treated this T input like an output, and I did a Carnot map where I had my SR and Q were my inputs, and this one I didn't use my Q star at all. My SR and Q were my inputs, and T was my output. So I put my T's in the Carnot map to come up with my excitation equation. Once I had my excitation equation, I was done, because then all I had to do was draw the circuit. Okay, questions?
That was a lot, but it was really helpful.
Yeah, it was a lot, but I thought that I think it was all useful stuff.
Absolutely.
Okay. Any anything else? All right then. Okay, good. Glad it helped. Okay, well, I am going to stop. I have something else I'm supposed to be doing in 10 minutes. So I'm going to stop and see if I can post some of these recordings for the people who couldn't be here. And I appreciate very much y'all coming. I know that it's hard sometimes to make it, but I appreciate it because I try really hard and it makes it worthwhile when people show up. So thank you so much.
Thank you, Rebecca.
You're welcome. See y'all later.